Hello friends, and welcome back to another episode of Spilling Studio. My name is Sam, and doing a bunch of practice questions was the biggest help to me when I was studying for my exams. So in this video, I've created 7 ARE practice questions designed to help you pass your next exam. There's one question per exam topic and a bonus question at the end, so stick around. Starting us off is practice management with a question on project delivery. Which of the following statements best characterizes the design-build project delivery method? Design-build separates the roles of the designer and builder, allowing for a more streamlined process and faster project completion. In design-build, the owner contracts separately with the architect and the contractor, ensuring a greater accountability and control over the project. Design-build integrates the roles of designer and builder into a single entity or team, fostering collaboration and potentially reducing project risk. Or, design-build is primarily utilized for large-scale governmental projects and is less suitable for private sector developments due to its complexity. Feel free to pause here to answer. The answer is, design-build integrates the roles of designer and builder into a single entity or team, fostering collaboration and potentially reducing project risk. Now, when I was studying for my exams, for some reason I used to mix up design-build and design-bid-build all the time, which is honestly kind of silly. I know they sound the same, but they literally describe exactly what they are. Design-build literally describes the team, a designer and a builder, and design-bid-build literally describes the process. Someone designs it, the project gets bid on, and then the contractor builds it. So don't mix these up like I did, even though they sound similar. Also, a tip for you. If you get a question on any of the exams, not just practice management, and they don't tell you what the delivery method is, then it's the traditional design-bid-build method. So, in design-build, the owner contracts with one entity. This entity is usually with a contractor as the lead and an independent architect as a subconsultant. With this method, there is one source of responsibility, the design builder. Construction time is typically faster than other methods, and the designer is able to get early construction advice from the contractor. The owner likes this method because they are able to get a cost estimate early on, since the contractor is involved in the design process and therefore is able to provide an estimate earlier. Some other project delivery methods are design bid build, construction manager as contractor, construction manager as advisor, and integrated project delivery. Design bid build is the one that sounds similar to design build, but this one is your traditional project delivery method. It's the method that most of the projects at my firm are on. With this method, the roles are clearly defined between the owner, architect, and contractor, and work moves in a clear, linear fashion. There are minimal coordination issues, and the owner is able to get a fixed price from the contractor before moving on to construction. However, the main disadvantage with this method is that it's slower, since the design has to be completed before moving on to construction. In CM as advisor, a third party acts as the owner's agent to consult on early constructability, provide early cost estimates, develop the project schedule, assist in negotiations, manage contracts, make early material purchases, and manage fast-track construction. Some of the disadvantages are the lack of competitive bidding and a more complicated management structure, since more people are involved in the project. In CM as contractor, the owner contracts with the construction manager for 2 phases, pre-construction and construction. So for this one, the CM is the one building the building. They do everything the CM as advisor does in the pre-construction phase, and then they build it. Integrated project delivery is a method that has all team members working together from the very start of the project. This is similar to design build, but the owner has multiple contracts instead of one. Since all team members begin working together at the very start of the project, this design phase typically takes longer than other methods listed here, but the construction is quicker since all team members were included in the design and know what the requirements are. This ends up leading to a shorter overall project delivery time. This method typically has lower construction costs, better design, higher quality construction, and fewer issues during construction. Next up is project management. Which of the following best describes a primary responsibility of a project manager in an architecture firm? Overseeing the architectural design process and making design decisions, managing the project budget and financial aspects including cost estimation and control, handling client communications and negotiations related to project contracts, or conducting site inspections and supervising construction activities on site. Pause here to answer. And the answer is managing the project budget and financial aspects including cost estimation and control. While project managers in an architecture firm have multifaceted roles, one of their primary responsibilities is to oversee the project's financial aspects. This includes managing the project budget, conducting cost estimations, monitoring expenses, controlling costs, and ensuring financial accountability throughout the project lifecycle. At my firm, just about everyone who is employed there is a project manager, and we do just about everything since we're a smaller firm. Roles are typically more clearly and strictly defined at larger firms. So this question may have stumped a few of you. So for the first one, overseeing the design process is typically your design lead or your design director. Client communications are sometimes handled by the project manager, but negotiations and project contracts are usually managed by your firm's principal, or you may have a dedicated contract manager who handles this. And lastly, conducting site inspections and supervising construction activities would not be the responsibility of an architecture firm. That is the responsibility of the contractor. We are responsible for conducting site visits and observing construction, but the last part of this answer, supervising construction activities, is on the contractor. Overall, the project manager's responsibility is making sure the project stays on schedule and on budget. Now on to programming and analysis. Which of the following urban development patterns typically radiates from a central point, often with main roads or avenues extending outward like spokes on a wheel? Grid, star, field, satellite, or megalopolis? Pause here to answer. And the correct answer is star. The star pattern of urban development typically radiates from a central point resembling spokes on a wheel, with major roads or avenues extending outwards in different directions from a central hub. This pattern often creates a layout where various neighborhoods or districts extend outward from a central core, allowing for easy access to different parts of the city or town from a central point. It's a common pattern in cities designed with a central focus or a significant landmark at its core. Think of the Arc de Triomphe in Paris. It provides a clear, structured layout from which other areas extend. The grid pattern features streets intersecting at right angles, creating a network of perpendicular roads. It forms a series of intersecting streets similar to a chessboard. The field pattern generally involves a more organic and irregular layout without a clear direction or pattern. It typically lacks the defined central focus that we see in a star pattern. Satellite patterns involve smaller independent centers connected to a larger central city or core, resembling satellites orbiting around a central hub. Megalopolis refers to a vast extending urban area that encompasses multiple cities and metropolitan areas, often merging into one continuous urban region. Let me know in the comments which pattern your city most resembles. My city is definitely a grid pattern. This week, our project planning question focuses on HVAC systems. And our question is, a large commercial complex in a region with extreme seasonal temperature variations is seeking a HVAC system that provides both heating and cooling efficiently. Given the priority for energy efficiency and flexibility, which HVAC system is most suitable for this scenario? Single split system with individual units for each room, variable refrigerant flow (VRF) system with multiple indoor units, packaged rooftop system for centralized heating and cooling, or constant air volume (CAV) system with central air handling units. Pause here to answer. And the answer is variable refrigerant flow system with multiple indoor units. A VRF system is well suited for buildings with diverse heating and cooling needs, especially in regions with extreme temperature variations. This system has an outdoor unit that contains a compressor that is able to vary speeds based on the needs of the indoor units. Refrigerant is circulated between the outdoor and indoor units through a series of pipes. Before the outdoor piping reaches the indoor units, it runs into a heat recovery controller. That little box manages the transfer and redistribution of heat and allows for simultaneous heating and cooling in the building. The pipes then go to the indoor units, which are installed in each zone. These can be ceiling mounted as shown here, wall mounted, or they can be floor standing units. Each unit has its own thermostat and controls the temperature. This system is energy efficient, allows simultaneous heating and cooling, and it reduces energy consumption as compared to constant systems. It also allows for great flexibility since you can have multiple zones and each zone can control its own temperature. This system is also one of the best for areas with extreme seasonal variations since it can switch from heating to cooling very easily. Our other three options were not the best option due to the extreme temperatures or because of the size and flexibility needs. Single split systems lack efficiency and control for large buildings as it operates individual units independently, leading to potential inefficiencies and difficulty in managing diverse heating and cooling needs. A CAV system typically operates at a constant airflow and may not offer the same level of energy efficiency or zone-specific control as with the VRF system, which adjusts capacity based on demand. And finally, the packaged rooftop unit system may be effective for some buildings, but in this scenario, it does not offer the same level of energy efficiency and precise zoning control as the VRF system, especially in large complex buildings with varied temperature requirements. Therefore, the VRF system best aligns with the requirements of energy efficiency and flexibility for a large commercial building in a location with extreme seasonal temperature variations. A brief pause here to remind you that I post new questions every week, so please hit that subscribe button to make sure you don't miss out on a video. It also really helps me out, so thank you. Now on to project development. The plumbing fixtures in a small commercial building consist of 8 flush valve toilets, 3 1-inch flush valve urinals, 4 lavatories, 2 service sinks, and 2 drinking fountains. What is the demand load for cold water? 81 fixture units, 106 fixture units, 121 fixture units, or 124.5 fixture units? Pause here to answer. And the correct answer is 121 fixture units. Now, before we even go into adding up numbers, we have to make sure we're pulling the right numbers. The question is asking about a commercial building, so our occupancy type will be public, and it's asking about cold water demand, not hot or total. With that in mind, we can then pull numbers from our table. 8 flush valve toilets have 10 fixture units of cold water demand, for a total of 80 fixture units. 3 1-inch flush valve urinals also at 10 gives us 30 fixture units. 4 lavatories at 1.5 gives us 6. 2 service sinks at 2.25 is 4.5. And 2 drinking fountains at 0.25 gives us 0.5. You multiply each of these and then add them all together, which gives you a total fixture count of 121 for cold water demand. Easy peasy, right? With this one, the math is simple, but you just have to make sure that you're pulling the right numbers from the chart. Next up is construction evaluation. During the construction phase of a commercial building project, the contractor submits an RFI seeking clarification on the design drawings related to structural components. As the architect overseeing the project, what is your primary responsibility when addressing this RFI? Providing a definitive answer without consulting other project stakeholders, reviewing the design intent and consulting with structural engineers if necessary before responding, directing the contractor to resolve the issue independently, delaying the response until the next project meeting for a comprehensive discussion. Pause here to answer. And the correct answer is reviewing the design intent and consulting with structural engineers if necessary before responding. The architect is responsible for overseeing the project's design and ensuring that the construction aligns with the design intent. If the RFI involves technical aspects related to structural components, it's prudent for the architect to consult with the structural engineers who are involved on the project. It's always important to check with your subconsultants to make sure how you're responding is accurate, especially if the response is changing something in the design. Responding to RFIs is covered in AIA document A201. Some of the options from the question, like telling the contractor to figure it out or delaying the response, contradicts A201, which tells us to review and respond to the RFI with reasonable promptness. So how do you know what reasonable promptness is? Well, it's in your specifications and may also be in your contract. This blurb here is from AIA's master spec, which is created by AIA and covers all the products an architect could need. This is taken from section 1, which are the general requirements portion of the spec. In this portion of the spec, it says to allow for 3, 7, or insert the number of days for the architect to respond. So the reasonable promptness depends on what this line says. I believe at our firm, we typically have 10 business days to respond to RFIs and submittals. We try not to use all of that time, but some RFIs can be complex and may require a lot of research or coordination between subconsultants, manufacturers, or possibly the contractor. Also, when the contractor sends you an RFI, they will typically include a response date of when they would like it back. That date may be a critical date, meaning that if the response is sent later, it could delay the project. So always do your best to respond sooner rather than later and communicate with your contractor to make sure you know which RFIs are critical. Last but not least, our bonus question is, in the construction of a modern commercial building with large window openings, the design team aims to select a material for the lintels that provides robust structural support and can span considerable distances without compromising aesthetics. Which material for constructing lintels would be most appropriate to support the large window openings in this scenario? Steel, concrete, masonry, or arc? Pause here to answer. And the answer is steel. So what the heck is a lintel? And no, it's not the edible kind. A lintel is a beam that is placed above a window or door to span the opening and support the load of the structure above. Steel lintels are made of 2 L angles that span across the opening. They are often preferred for their high strength to weight ratio and ability to span larger distances compared to other materials. They offer exceptional structural support, allow for larger window openings without compromising on stability. Steel can also be fabricated into various shapes, profiles, providing flexibility in design while maintaining a modern and sleek aesthetic appeal. Concrete lintels can offer structural support but might have limitations in spanning considerable distances without additional reinforcement, and they might not align as well with the modern aesthetic sought for the commercial building in this scenario. Masonry lintels would not be suitable for spanning large distances without intermediate support, and they may not offer the necessary strength or sleekness desired for a modern commercial building. The term arc here refers to an arch lintel made from masonry. While an arch design distributes loads efficiently, an arch lintel would likely not meet the span needs for a large opening. Considering the need for robust structural support spanning considerable distances and maintaining a modern aesthetic appeal for large window openings in a commercial building, steel lintels are often preferred due to their strength, versatility, and ability to achieve desired architectural aesthetics. That's our questions for this week. Remember to check out the description for links to some of the AIA contracts covered in this video. I've also linked some of my favorite study books, so go check those out. Let me know in the comments what areas you're struggling with, and I'll do my best to cover it in the next video. Thank you all for joining. Please subscribe, and good luck on your next exam. You got this!